so here we have to find the second degree Taylor polynomial for the function 4th root of x centered at 16. Okay, so let's deal with that center first of all. So f of x is equal to 4th root of x, or x to the power of 1 over 4. And now let's center it at 16, so that's x minus 16. If I subtract 16, I have to add 16, the whole thing to power 1 over 4. And then we know the binomial, right, is 1 plus, let's say, u to the power of k. And this is going to be 1 plus k times u plus k times k minus 1 over 2 factorial u squared, and so on and so on. So I know what my k is. K is 1/4. Now I want to adjust this expression to look like 1 plus u, and to determine also what my u is going to be, right? So how are we going to do that? We will factor 16, and I have 1 plus x minus 16 over 16, the whole thing to power 1/4. Now this is 16 to power 1/4 times 1 plus x minus 16 over 16 to power 1/4. Or simply 2, right? The 4th root of 16 is 2 times 1 plus x minus 16 over 16 to power 1 over 4. And this is my u. Okay, so I can expand. I'll have 2 times the first term is always 1 plus k, which in our case is 1 over 4, times u, that's x minus 16 over 16, plus 1 over 4 times 1 less, which is negative 3 over 4 over 2 factorials, times x minus 16 over 16 squared, plus 1 over 4 minus 3 over 4 times negative 7 over 4, 1 less than negative 3 over 4, over 3 factorial x minus 16 over 16 cubed, plus, and so on and so on. But since the question says write down the second degree Taylor polynomial, we have to stop with the term where x is raised to power 2, so up until here, which gives us the second degree Taylor polynomial to be equal to 2 times 1 plus 16, x minus 16 over 4 times 16. Positive times negative is negative, 1 times 3 is 3 over 4 squared times 4 times 4, 4 squared, times 2 factorial times 16 squared, and here I have x minus 16 squared. Now we can rewrite this in a nicer form, multiply everywhere by 2, plus x minus 16, right? 2 and 4 will cancel, 2 times 16 is 32, minus 2, and this 2 factorial will cancel, and I have 3 times x minus 16 squared over 4 squared is 16 times 16 squared is 16 cubed. Okay, so this is our second degree Taylor polynomial. Now it says use this polynomial to evaluate 4th root of 15, right? So 4th root of 15 will approximately be equal to this Taylor polynomial, quadratic polynomial evaluated at 15, and that's 2 plus 15 minus 16 over 32 minus 3 times 15 minus 16 squared over 16 cubed, which is 2 minus 1 over 32. This is negative 1 squared is positive, minus 3 over 16 cubed. And now you can evaluate this. Minus 1 over 32 minus 3 over 16 and I get 1.9680176. Now, of course, you can simply calculate what's the fourth derivative of 15, and you'll see that you're going to be very close to this. So, sorry. So, yes, the fourth derivative of the actual, if you actually plug in fourth derivative of 15, you'll get 1.96, and here is 79, and so on and so on. Okay. So now the last thing it says, give a bound on the error of this estimate. Okay. So basically, if we have used the second degree Taylor polynomial, now we want to find how much is the bound of the remainder, right? And we said that this is less or equal to absolute value of the derivative of the function. What derivative? So if this is the second degree Taylor polynomial, this is going to be the third derivative evaluated at some value over 3 factorial times x minus the center, which is 16 to the power of 3. Now we have to find the bound on these two, right? Well, if the center is at 16 and I'm evaluating how much is 15, right? So x can run anywhere between 17 and 15. So x is anywhere between 15 and 17. Okay, so first of all, we have to evaluate the third derivative of the function, which is going to be very easy, right? So f of x is equal to x to the power 1/4. The first derivative is 1/4 x to the power negative 3 over 4. The second derivative is negative 3 over 16 x to the power negative 7 over 4. And the third derivative is 21 over 64 x to the power negative 11 over 4. So let me rewrite what was written in the previous page. Is less than equal to the third derivative evaluated this value that runs from 15 to 17 over 3 factorial x minus 16 to the power of 3. Okay, so this is equal to the third derivative is 21 over 64 times 3 factorial, right? And in absolute value, x to the power negative 11 over 4 times x minus 16 cubed. This can be rewritten as 21 over 3 factorial times 64 times x to the power 11 over 4 times x minus 16 cubed. Okay, because this x here appears in the denominator, and we know that x runs from 15 to 17, right? I'm going to take the lower bound, so this is definitely less or equal to 21 over 3 factorial, which is 6, times 64 times, so this, because now this is less or equal to, if I take the lower bound here, because x is in the denominator, so that's 15 times 11 over 4. This is in the numerator, so I'm going to take the upper bound, but because it's in absolute value, actually it doesn't even matter here. That's 17 minus 16 to the power of 3. This is only 1, so I get 21 over 6 times 64 times 15 to the power 11 over 4. Now I want for you to write down this expression, on your assignment, on your test, on your final, okay? And not just to give me a plain, the final answer right here, because I want to see all of these bounds, okay? And finally, you can simply calculate how much is this, and that's it. The problem is that I still don't know how to work with this new calculator. So this would be this would be the final answer for today.